Okay. So Euler's theorem on homogeneous functions. Now, from what we established earlier, I said z is equal to x to the power n, a function of y over x. Let z let this expression be homogeneous function, be a homogeneous function of x and y. Then, Euler said that x partial z over partial x plus y partial z over partial y is equals to nz. You could check your textbook. They actually derive this stuff, but you don't need to learn how to derive it. I'm not sure any lecturer, although I don't know how your lecturer be. I'm not sure any lecturer ask you to derive it. So just know this formula. We are trying to be smart with our preparations, so just know this formula. Now let's apply what Euler have said. Euler boy, given that f of x comma y is equal to x to the power 3 plus y raised to the power 3 minus 2x squared y, show that x partial f over partial x plus y partial f over partial y is equal to nf. Recall your n is the degree. When you've checked for homogeneity, the degree to which the function is homogeneous, that's your n. So you're giving this you're giving f to be this. F is equal to x to the power 3 plus y to the power 3 minus 2x squared y. F is equal to x to the power 3. Okay, we say let's take the highest power of x. So factorize the highest power of x. You have x raised to the power 3 brackets 1 plus y over x raised to the power 3 minus 2 brackets y over x. X cancels this x raised to the power 3. You have x squared, so you have x over y. So this satisfies this equation. This is also satisfied. This also satisfies this equation. So the function is homogeneous of degree 3. It implies that n is equal to degree 3. So now the square f over dx is our f. Differentiating with respect to x, you have 3x squared minus 4xy. The f over the y, differentiate this with respect to y, you have 3y squared minus 2x squared. Now straight up, they said you should prove, right, or show that. You have to show that x, the f over the x plus y, the f over the y is equal to nf. So we want to show that. Let's start with showing the left hand side. Take it step by step to show each side, then consider both of them. So showing the left hand side, x df over dx is equal to x times this. This is what you get. Y df over dy is equal to y times this. This is what you get. Also, I'm not saying this is what will come out in your exam, but I'm just like, these are things you need to take note of. Then also work with some questions, but get the basics first. For mathematics, I won't suggest, I will never advise you to use past question as your guide for reading. No, yes, don't even use it as your guide. Just learn what you've been taught. Cover your syllabus or cover your course content. See me, a whole course outline. That's what we used to call it. So that's what you just need to do. For mathematics, it has happened to me in 2 semesters. I tried to use past questions as my reading guide, almost messed me up in exam. So just cover up what you're giving, the course outline, then you now use past questions to test yourself and gain experience. Alright, so back to this. So for the left hand side, x df over dx plus y df over dy is equal to this. Is equal to this. Simplify it, you're going to this minus this will give you minus 6. So that's your final answer. We call this equation asterisk. Now also for the right hand side, it said nf. It said show that is equal to nf. Nf is equal to 3f. Our f is this, so you have 3 times f. This is what you get. We call this equation asterisk asterisk. So now considering equations asterisk and equation asterisk asterisk, we have that x the f over the x plus y the f over the y is the f over the y is equal to 3x raised to the power 3 plus 3y raised to the power 3 minus 6x squared y. which is equal to nf. So we're proving that the left hand side is equal to this and the right hand side is also equal to this. So that's clear. Now we have another example here, a funny one too that you also need to take note of the approach. Now if sine u is equal to x square y square all over x plus y, show that x partial u over partial x plus y partial u over partial y is equal to n tan u. Solution, we check for homogeneity. You check the top is x to the power 4 y over x square. The denominator is just x, 1 over y plus x. You cancel, okay, laws of indices, collect the base minus the power, so you have x to the power 3. So this function is homogeneous of degree 3. The function is homogeneous of degree 3. Alright, so it implies that x du over dx plus y du over dy is equal to 3 tan u. That's just like, I was just trying to let us know that's what we need to get. So we said let z be equal to sine u. Let z be sine u here, see sine u here. So now let's call this sine u z. It means that z now, if this is z, z will now be a function of x and y. Z is a function of x and y. So if z is a function of x and y, then we can find so listen now. Z is equal to sine u. If we put here sine u now is equal to z, z will be equal to this. So z is a function of u and z is a function of x and y. Original value of z is actually u, but now z is also a function of, but u is a function of x and y. No, sorry. Z is a function of u and u is a function of x and y. So z can also be a function of x and y. You understand what I'm saying? So these like that explanation I was making. Z is equal to sine u. So z is a function of u. But u now, sine u is equal to x square y square all over x plus y. So it means that z can also be equal to x square y square all over x plus y. Alright, so partial z over partial x is equal to partial z over partial u times partial u over partial x. From you know that stuff we did. If you just check the previous video, or check some other videos if you've not watched that one. So this is what you have, and partial z over partial u. Can we take a look at this to know how we got cos u? Okay, here it is. Z is equal to sine u. So differentiating this with respect to u, partial z over partial u is equal to okay, I don't think we should use partial. We should use normal d here. Since z is just a function of u, it's u now that is function of x and y. You see? So I also need my own explanation, sir. So dz over du is actually cos u. Dz over du is also cos u, but we don't know partial u over partial x and we don't know partial u over partial y. So dz over du is cos u, so this is now cos u, the partial u over partial x. This is cos u partial u over partial y. Yes. So since z is equal to sine u and z is also a function of x and y, x dz over dx, x partial z over partial x plus y partial z over partial y is equal to nz. Now we are working with terms of z, so we are using Euler's theorem on homogeneous function, the first one for just a single distance for first order. Okay, so this is Euler's theorem for first order homogeneous function. Recall first order has to do with the power attached to the d's. So the power here is 1, so this for first order. So we are working with z, so we use Euler's this thing for first order. So x partial z over partial x plus y partial z over partial y is equal to nz. Now the z over the x, the z over the x is equal to the z over the x is equal to cos u du over the x. So x cos u du over the x was y. The z over the y is cos u du dy plus y cos u du over the y is equal to, our z is sin u, is equal to n sin u. You get, take out cos u, factorize cos u brackets x du dx plus y du dy. Our n is 3. We established that earlier. The function is homogeneous of degree 3, so our n is 3 sin u. Alright, so x du over dx plus y du over dy is equal to 3 divide both sides by cos u, so you have sin u over cos u. X du over dx plus y du over dy is equal to 3 tan u. So what am I trying to say is that sin u divided by cos u is tan u. Let's show it. You have SOHCAHTOA. What we are saying is for sine is opposite over hypotenuse divided by cos is adjacent over hypotenuse. When you change this to multiplication, you have opposite over hypotenuse times hypotenuse over adjacent, right? This will give you opposite over adjacent, which is tan. So sin u over cos u is tan u. Alright, so this is show like all the way to actually prove this stuff, but yes, you actually need to take note of this pattern. Alright, so that's it for now.